Hi everyone, welcome to Maths World. In today's video, we are going to discuss about properties of integers. Second property, that is commutative property, we are going to discuss. In the previous videos, we have discussed first property, that is closure property. What is closure property? Closure property means if we take a and b, a plus b also an integer, that is called closure property. Coming to the commutative property, so we are going to take any two integers, and by checking the principle, we are going to decide integers commutative property is possible or not in addition and subtraction and multiplication and division. So if we take a comma b, or integers, or a comma b belongs to z, so we are going to check a plus b equal to b plus a. So if integer system satisfies this equation, we can decide that we will decide that commutative property is possible under addition. Each and every property we are going to discuss under addition, under subtraction, under multiplication, and under division we are going to discuss. So at first commutative property under addition we are going to discuss. So by taking example, we are going to discuss about or we are going to confirm commutative property under addition. Okay, that is commutative property under addition. We are going to check now. Okay, so if we take a comma b are integers, so a plus b is equal to b plus a, we are going to confirm this equation. So if we take any two integers, that is a is equal, for example, that is a is equal to minus 4, b is equal to 2. So you can take any integers, positive or negative integers. I am going to check it first LHS. So LHS is equal to a plus b. So a means minus 4 plus b means 2. Minus 4 plus 2 is minus 2. So I am going to check now RHS. So RHS b plus a means 2 plus of minus 4 means 2 plus into minus, minus 4. 2 minus 4 means minus 2. I am getting LHS minus 2, RHS also minus 2. LHS is equal to RHS. LHS is equal to RHS. By this we can generalize that commutative property under addition is possible. Next we are going to check commutative property under subtraction. So now we are going to check commutative property under subtraction. Okay, subtraction. Okay, in this subtraction also we are going to take two integers, a comma b belongs to z. A comma b belongs to z. A minus b is equal to b minus a. If the integer system follows this equation, then we will decide that commutative property under subtraction is possible in integer system. For example, we are going to check with by taking an example, a is equal to 5, b is equal to minus 1. So if we check a minus b or LHS is equal to 5 a minus b, that is 5 minus of minus 1 means 5 is equal to plus minus into minus plus 1. 5 plus 1 6 we are getting. And then coming to the RHS, so b minus a, that is minus 1 minus of 5. So minus 1 minus 5 means minus 6. Same sign integers we are going to add them. So we are getting LHS has minus 6, LHS has plus 6, RHS has minus 6. So LHS is not equal to RHS means a minus b not equal to b minus a. That is by this we can generalize that commutative property under subtraction is not possible in integer system. So next we are going to discuss about commutative property under multiplication. Commutative property under multiplication. Okay, so this is same as addition property. So a comma b belongs to z, that is a b are integers, so a into b is equal to b into a. If the given integer system, that is integer system, satisfies this equation, we can generalize. So by taking an example, we are going to check this. So if you take a is equal to -5, b is equal to -2, you can take any integer, positives or negatives or 0. So I am going to check LHS at first. So LHS, what is the LHS equation? A into b, that is LHS. A into b means -5 into -2, minus into minus, plus 5 to the 10. Next, coming to the RHS, b into a, that is -2 into -5, minus into minus, plus 2 5 is 10. So we are getting LHS plus 10, RHS also plus 10, that is LHS is equal to RHS. So by this we can a into b is equal to b into a. The integer system is satisfying this equation, means commutative property under multiplication is possible in integer system, we can generalize. So by this we completed addition, subtraction, multiplication of integers commutative property. Now we are going to check commutative property under division, we are going to check. Okay, so division. In this division also we are going to check a division b equal to b division a. If a comma b belongs to z or a comma b are integers, we are going to check a division b equal to b division a. That is, if an integer system follows this or satisfies this equation, we can generalize. Okay, by taking an example, I am going to check. If we take a is equal to -3, b is equal to -3 or -2, you can take any or 0, you can take any number. Okay, let's just say a division b is equal to -3 division -2, that is -3 by -2. So minus minus cancel, 3 by 2 is the answer. 3 by 2, that is we get a fractional number. I am going to check RHS. B division a, -2 division -3, -2 by 3, we can write it as minus minus cancel, 2 by 3. So LHS we get 3 by 2, RHS also, RHS we get 2 by 3. So 3 by 2 is not equal to with 2 by 3, that is LHS not equal with RHS. So by this we can generalize that integer system commutative property under division is not possible, that is a division b not is equal to b division a. So by this we can generalize the commutative property under addition, under division, under multiplication. So we are going to generalize. So tell me now commutative property under addition and subtraction, multiplication, division possible or not. Okay, so commutative property under addition possible or not, subtraction possible or not, multiplication possible or not, we are going to generalize. Okay, so commutative property under addition is possible or not, tell me. Under addition possible, under subtraction possible or not, not possible. Under multiplication possible or not in integer system, possible. Under division is possible or not, not possible. So under multiplication is possible, but under division is not possible. Commutative property in integer system, we are going to generalize. By this we completed the commutative property, and in the previous class closure property, commutative property we completed. So I think you understood well. Please like, share and subscribe our channel. Thank you. Thanks for watching.